Welcome back to another edition of Are You a Robot? This is a series where we aim to tackle some of the greatest challenges that stem from AI and related technologies. The way that we're doing that is by gathering the brightest and best minds in their respective fields, whether that is a machine learning researcher, an AI ethicist, or a lawyer, a government official, you name it. We're trying to get them all on here to talk to us about AI and the ethical related issues that come with it. So, we do not finish the conversation here. Please, if you enjoy anything that you hear, jump onto our Slack community. You can find a link to that below in the description and introduce yourself. Let us know what you're working on, how you see the world, what you think is an important topic that we should be covering when it comes to AI ethics. Last but not least, for all of those people out there who have been listening from the start, you know that EthicsGrade is our sponsor. They are doing a phenomenal job. I really want to thank them for keeping this show in business, as we could say. And if you don't know who EthicsGrade are, you can check them out in the link below. They're an ESG benchmarking firm. So they are specifically targeting or looking at the ethical implications that companies have around their AI programs. Right now, they launched a cohort of data with all of the different ethical benchmarks or ratings of all of these big companies that you have heard of, like TikTok or Twitter, and you can compare these companies to see how their AI ethics programs match up against one another. So you can see what Amazon is doing and how they compare, what kind of grade they got compared to Alibaba or Microsoft. So if you want to learn more about that, I encourage you to click the link below, have a little play on their website, see which companies are doing AI ethics right and which ones could use a little more help. That being said, let's jump into the conversation now with Stephan.
Are you a robot?
Stephan, it's a pleasure to have you here. I'm excited to talk about what you've been doing with the AI Economist. I think it would probably be useful for those listeners out there if you could give us a bit of background on how you got into tech and how you find yourself where you are right now doing this ML research.
Yeah, that's a great question. I actually studied physics and math in undergrad. I was always fascinated by how the world works, thinking about this big and the small. And after a number of years studying physics, I basically got really interested in how our brain works and how intelligence works. And so I made a switch. I basically started to talk to several people who worked in machine learning, and one of them became my PhD advisor. And I was sort of fascinated by the speed at which you can try new things and test ideas. Because in physics, I used to study theories, right? And people were talking about black holes and the Big Bang, and turns out you can't have two Big Bangs just like at the snap of your fingers. But my PhD advisor basically gave me a data set with basically recordings of the NBA, the American Basketball League. And so, I would look at my computer, and then you would basically be able to animate, Kobe Bryant, for instance, I was pretty sure he was somewhere in there. The fascinating thing about AI and tech is that, for me, it combines this mathematical rigor that you have to bring to the research, but also you can try out and develop things really quickly. And I think that combination is really compelling. And that's how I got basically fascinated by this field.
So the iteration, the quick iteration, and the ability to really make an impact on things besides, or try to understand things that are less time consuming than a big bang. I could see the appetite there for trying to take on some of these problems. Now let's shift over to what exactly is the tax dilemma that you speak about. What is this problem that you're trying to solve?
Right. Yeah. So taxation is a lot about making a decision on a certain trade-off in society. So the idea is that we as a society need to balance things like equality and productivity and other metrics that you might care about. And so taxation is one way in which the government can raise funds, and those funds can be used to invest in society, to subsidize infrastructure projects, or to subsidize households directly. And so taxation is a really important tool in which we can try to make society better. But at the same time, the problem is that of any policy, including taxation, is that you need to understand how people respond to it. Not just people, how all kinds of, any actor in the economy, how they respond to taxation and change in taxation. And so the dilemma is that you can't tax too high, you can't tax too low. And so the question in a lot of these problems is really to understand what the effect is of too high of taxation or too low of taxation, because people are going to respond in very complicated ways. And so that's the dilemma for anyone who studies that problem.
So can you talk about these different complications that come up and how you found out about them? How do you discover the different ways that people react to different taxation? Is it just, well, I'll let you explain it.
No, that's one of the essential questions. So in our research, we basically use this simulation of an economy, and in this simulation, there are AI agents, and these AI agents are working, and they're making money. So that's just like in the real world. And the idea is that all these agents, they try to be as happy as possible in this world, right? So and so each of these agents has this balance between making money, but also having to work for it. And there are differences between these agents. So not every agent makes the same amount of money for the work that they do, or for the type of work they do. So there are also different types of work in the simulation. And so what you can see is that, like, when we study this problem of taxation, what the AI system is doing is saying, well, I have this objective of trying to maximize some combination of equality and productivity in this world, and I can achieve that by using taxation. And then so all these AI agents in this world who are working, they are going to experience different levels of taxation. And then every AI agent individually can then decide, for instance, what kind of job they want to do, or how much they want to work. And this is similar in the real world, because if you tax people too much, for instance, then your hourly wage goes down. And so you might be less incentivized to work an extra hour, for instance. And what this setup allows us to do is that you're using the simulation of these AI agents who experience all these different taxation systems. And then there's this outer sort of system where that system is observing how the economy evolves. And then based on that, it tries to figure out, like, what the optimal tax policy is.
And if I understood correctly while reading the paper, it's that you did many of these simulations.
Exactly. Yes, and that's the power of this computational approach. We can simulate these economies. You can put on 1,000 simulations in parallel, if you will. It's kind of like the multiverse. If you watch Marvel the Avengers, right? It's like many worlds in parallel, and in every world there's a slightly different future that's playing out, right? And then the system as a whole can compare all these different universes and say, okay, which one seems to be better, which one seems to be a bit worse, and then based on that, we're going to figure out what the best tax policy is.
What are you optimizing for? How do you know one is better or worse? Like, what does better mean?
Yeah, that's a great question. The beauty of this framework is that it's agnostic to the objectives that the government has. So as a human designer, you can set that objective. And in fact, we don't say what's better or what's worse. Equality and productivity are interesting because it really gets at the heart of what economists would sort of consider one of the big problems, basically, in taxation. There are different ways of framing it, but again, it's about this tension between taxing people too much or too little. And so for us, if we look at the economics literature, that's a very natural way of framing the objective. But there are different ways in which you can combine equality and productivity. So for instance, you could say, I care equally about both. Or you could say, I care a little bit more about productivity, a little bit less about equality, or vice versa. And in our work, we don't say anything about what's better, what's not. That's more of a social normative problem, and we don't say anything about that.
And this is to be used, like these simulations are meant to be used by policymakers to help them guide their decisions, or do you foresee one day that it completely takes over and it is the policymaker?
No, I don't foresee it completely taking over. It's definitely not now. The current economic simulation looks more like Pokemon than an actual world. So we are AI researchers. We focused a lot on the learning problem, because the meat of the science that we've done is really to figure out how the learning works in this world where all these individual agents are learning to adapt to the new economic situation, and the government is learning as well. So for now, I would see this more as a proof of concept of this, the fact that this learning problem is feasible, that you can actually solve it with the tools that we have. Perhaps in the far future, as the simulations become more realistic, it can become a guidance tool or some sort of. One way to think about it is that it's a little bit like a weather forecast, right? Where you can sort of see a little bit into the future and say, what if we do this? What does like a plausible future look like? But it's never going to completely replace people, I would say, because, for instance, the fact that the objectives are free, right, means that people need to decide how this framework is used, right? So I don't foresee this completely replacing people.
So let's talk for a minute about how you even came to this problem. How did you decide that this was something that you wanted to work on?
Yeah, it's always interesting to just look back, and it's tempting to say that one day there was a magic light bulb or something like that appeared, but in reality, it was a much more organic process. So after my PhD, I mentioned that in the start of my PhD, I worked on this basketball data. And one of the fascinating things about that is that this basketball data captured teamwork because it had two teams of 5 players trying to coordinate, trying to work together. And so one of the big questions is that the fact that we live in a world with other people, right? It points to the fact that intelligence evolves partially because it is in an environment where it has to interact with other people and other kinds of entities. So I basically, after my PhD, kept working on that, and there are a lot of sort of algorithmic problems that you can frame within the setting of having multiple AI agents. And so initially, we didn't really talk about economics. I was more interested in sort of how, for instance, things like teamwork emerge from a collection of AI agents learning together. And what the interesting thing about that is that, it sort of gets back to this question of like, what is the objective, right? Like what is the objective? And if you think about how it goes back to the core of like how people, your objective and my objective, right? What do you want out of life, basically, right? What makes you happy? Because why would we even work together as a team, right? Or why would people band together in like a village, for instance? And so it became clear after a while that like it's basically about incentives. The question is, what is the incentive for you to work? What is the incentive for you to go on vacation? What's the incentive for you to be a good person, right? And when we realized that, okay, well, it's about finding the right incentives in a way that's basically one way to motivate or stimulate teamwork. That got us into economics, because then the question was, how do you design the incentives for this collection of AI agents such that they work together well, right? Or such that society is better off. And so at some point, the notion, like the light bulb, I guess, if there was a light bulb moment, was that, okay, incentive design is actually what a large part of economics is all about. Because in economics, right, people talk a lot about like, what are the right incentives? How do we incentivize, people, companies to do certain things? And that got us into this like sort of mode of like researching, okay, well, what is known in economics about this incentives design in a world where everyone's kind of being strategic, where you have these AI agents. And it turns out that economics actually as a field does not really use AI. It hardly uses AI today for many reasons. And so we discovered actually there's this really exciting opportunity to bring these tools from AI into the field of economics, because one thing, for instance, is that these simulations in which we have these AI agents that are being strategic, that feel the same drive to work or drive to not work, to go on vacation, that's the kind of like behavioral model that economics lacks, right? And the fact that we can like do these kinds of analyses much faster in a much richer way, we actually sort of stumbled into seeing that this is actually a really exciting research opportunity and really a chance to bring these two fields together more than before.
So talk to me about other areas you feel this could be applied, whether that's within economics or just in the broader terms of how you can take this technology or these incentives, as you speak about, and apply them to other hard problems.
Yeah, that's a really interesting open-ended setting. One of the other domains that has come up that I've not worked on, but it's really education. So if you think about it, like how do you, when a teacher is in front of a classroom of kids or running a MOOC, right, these days, I guess, or an online class, a lot about it is like, how do you make sure that a student learns, math or English or French. How does that work, right? And if you think about it, a lot about that is really tricky because you have to understand what is the skill level of this student right now, right? What kind of exercises or explanations do you need to give to the student to make sure that the student will improve? And as a teacher, right, like you're basically trying to design this curriculum and personalize it to a student. And at the same time, the student is learning, and obviously not every student wants to sit in this class all day. So hopefully it doesn't take 10 hours a day to get through the curriculum. And so actually the student-teacher relationship is actually one that's actually very similar to people in the government, if you will, to some extent. I'm not making any sort of philosophical analogies here. I'm just saying that mechanically, the idea is that the teacher is trying to be smart about how the curriculum works, and then the student is trying to be smart in terms of improving itself, and also having enough time to play around with their buddies. So that's another area where you can see that this incentive design and curriculum design is potentially useful in the future.
Mm. Yeah, that's fascinating. It's something that you hear AI being thrown around a lot when it comes to education, but not in this way. You see a lot of AI, okay, it helps you because it will give you maybe the best way that you can learn, or through these Zoom calls, you have some kind of AI agent that's there helping you along, but not in a way that's talking about the incentives and how we can help teachers create better curriculums that incentivize the students in a way that they learn and it maximizes their potential. So I like that. I like the way that you think about that. Are there any other applications that you've thought about?
There are applications around. There's me sort of brainstorming, but I haven't thought a lot about other, actually working on applications right now. But you could imagine that, for instance, if you design a highway system, and in the future, near future probably, we'll have a lot of self-driving cars. That's actually another example of such a system. Again, like everyone's driving in their car, and you try to avoid traffic jams, right? And so there's this interesting problem. Like I lived in LA actually for 5 years, and anyone who's from LA, right? Like people will talk about not the weather, but they're going to talk about, because the weather is typically very nice in LA, but they're going to talk about the highway and it was very busy in the 101, but today, the traffic jam only lasted for 10 minutes instead of 15 minutes. And the interesting thing there is that, again, there's two levels really in the system, right? And so just like there were students and teachers, taxpayers, and the government, in traffic, there's people who are driving in their cars. And so people obviously want to try to avoid traffic jams. We use apps like Waze, and there's a bunch of other apps that can help you try to avoid traffic, right? And at the same time, there might be a traffic controller or a local, I'm not sure how you call these authorities, but somebody thinks about where to build new roads, for instance, right? Somebody thinks about where to build new highways or where to expand highways. And obviously that's a choice. Yeah, you have a planner who basically tries to figure out, okay, assuming that people are going to behave in such and such a way, here's the best place to improve and expand the infrastructure. That could be another example where, again, you have this two-level structure or relationship between individual car drivers and some traffic planner.
So can you talk to me about these two levels that you're speaking of, have you tried to, and again, I'm brainstorming with you right here, have you looked at if there's more than two levels, if you can make an effect, or does the complexity just get out of control? And I don't even know what a specific use case for that would be, but right now you've been speaking a lot about use cases that have two levels, right? Maybe there is a use case that you've thought about bringing another level on top of it, where there's another oversight or another something that is involved and is a stakeholder in this. And would, or have you thought about that?
Yeah, it's something that we've been thinking about, and I think if you even if you just extend this notion of government, there's different state level, federal level, local level governments in the U.S., and so you can think about that as multiple levels. These authorities all interact with each other. And yeah, going back to the education setting, you have multiple teachers as well, right? So multiple teachers for different types of classes or courses. You have you have higher teachers among different grades. And so in reality, it's rarely the case that you just have one teacher, right, or one government. So that's one way in which you can think about extending it, or in the way in which extensions of this multi-level, this hierarchy makes sense. And if you think about the real world, there's more than just taxpayers in the government, right?
Yeah.
So there are companies, there's utility companies, there's regulators, there's many actors. In reality, what we have is a really complex network, right? Of actors that all are incentivized to do one thing or another. And a lot of social psychology basically is all about that, right? Like social networks are group of friends. We all have like this interesting like web of relationships around us. That's very different from what we've been talking about. But again, you can imagine that like we are influencing each other's incentives. For instance, like if I see a picture of somebody on social media and that person is on vacation, right? It sort of triggers this thought in me that, oh, maybe I also want to go on vacation. And now I'm actually less incentivized to work and I'm more incentivized to go book a trip to like a sunny beach somewhere. So the interesting thing is that going back to this question of like, what is intelligence really? And a big part of that story is how our behavior influences other people's behavior, right? So in reality, like, because we are all sort of interconnected that way, I think the idea of multi-level learning or hierarchical learning, that is a very powerful concept, and it's something that, in fact, like if you look at the scientific literature, it's one of these problems that is extremely hard to analyze. And so I think that is going to be something like the new frontier, basically, when it comes to, if we think about, 5 to 10 years ahead, like what are the kinds of phenomena that will be interesting to study with this new technology? I think that sort of social complexity or multi-agent complexity is something that's going to be more and more interesting to study.
Yeah, lots to unpack there. You make so many valid points, especially this idea of how we are interconnected and we are influencing each other. How can you build a model, or how can you create some kind of AI or machine learning that takes that into account and does it in a way that is mirroring what we do as humans? So that moving forward is a very interesting problem to study. There's something that I got to ask. This AI economics problem that you've been working on, it has nothing to do with the bottom line of Salesforce. What, can you explain how Salesforce is involved in this and why they told you or they allow you to go and work on this kind of stuff for your research?
Yeah, so Salesforce is a company that basically does business for to service customers, but also to improve society, right? So one thing that distinguishes Salesforce from a lot of other companies is that it very explicitly has societal benefit as a strong value in the company. And so in the AI research team, what that means is that part of the team that I'm part of, we do fundamental research where we believe it will help improve society. It also improves just the science of machine learning. And that is part of the way in which Salesforce contributes to that development. And a lot of the that research for that reason is we hope to show or to bring interesting ideas into the world where we believe it will benefit society in the long run as well.
So talk to me about some potential downfalls with this model or this AI that you've created. What are some things that aren't necessarily like, that they're wrong, but it still is a great leap forward, what you've done, what you've been able to show. It's just that, we still need to work on this part.
Yeah. One thing that is one thing that is still something that's active research is notions of explainability. And I wouldn't say it's wrong. It's something that is right now, because we use neural networks, and neural networks are very powerful models because they can, for instance, emulate this human behavior. But because they are complex, it's also harder to explain sometimes what the cause-effect relationship is between their behavior, right? So you might ask, like, why did this neural network respond in such and such a way? So I think that one very good opportunity for the future is to do more analysis on this explainability factor, right? So that would make the policy behavior more interpretable. And another thing is the simulation, right? The simulation is very simple, and that's okay because we're focused on this computational problem. But moving forward, I think a big question is, like, how do you build a better simulation? What is required for that? And when is it enough, right? Because it's for many reasons, that it's probably very unlikely that you're going to have a perfect recreation of the world. So one of the questions is, like, how do you ensure that your simulation is good enough? And what does that even mean? I think that's one of those questions that are just inherent to the problem, and I think it's really important to pay a lot of attention to that kind of question. So those are two things that I would think about.
So that question of how do you know when it's good enough? What are some answers that you've thrown around? I imagine you talk about this quite a bit with your colleagues.
Yeah, one thing that is super important to us is that it includes notions of fairness in the future. So if we're really talking about simulating a real economy with all its diversity, the diversity has to be represented, right, in a simulation. So that is very important to us. So when I say good enough, it means that the simulation is fair. The simulation also has to be accurate, so it has to capture enough of the complexity of a real economy that matter for the policy problem that you're interested in. So just to give an example of that, let's say that you're really interested in taxation of incomes. Does it matter that the sun went up every day? It's probably less important than some other, economic things that are going on. So they're. I think when you build these kinds of simulations, they can be really useful. But there's also a challenge because you're trying to recreate this web of complexity, and that requires a lot of new science that you need to do in order to understand how to capture that complexity in the right way. And I think that's really exciting. But it also, that's just kind of like what Spider-Man says, right? Like with great power comes great responsibility.
Yeah.
And with great complexity comes great responsibility. I would say that's sort of the analogy I would make there. I think that's where really responsible research really has to shine.
So, talking about the complexity of this, do you feel that this could be something that is used on a global scale, or is it more on a micro scale?
I think it could be used at a global scale in the future. I think certainly that is one of the compelling use cases to give some insight in what is actually a very, very, for many reasons, a very tricky problem. Mm-hmm. It could be used at the local level as well. It could be used for all kinds of other problems. There's no real limitation in that sense to this framework. But it does require a certain maturity when it comes to our understanding of the problem. It comes with a sense of maturity, for instance, of the data that you might use to inform such a simulation or to inform future models. So I think that there's some limitation in that sense, but maturity is required.
And speaking of the data that you're using, can you walk us through what that data is? And I continue to think this is a little bit off topic on that question, but I keep thinking about the idea of how when you are taking an action on something that a machine learning model is predicting, you're influencing that action, right? Or you're influencing that machine learning model in a way that, right now, we could use a simple churn prediction. And so a company that is taking an action when they get a prediction from a machine learning model saying, hey, this customer is probably going to churn, then the company's not going to sit back and say, okay, let them churn. They're going to take that action. And I think about how with this, it's a little bit like that. Like if you were to create these different models and you're going to have people that are taking actions on them, it's always going to be, it's like you're not ever going to see what the actual outcome of these predictions are? Or am I totally mistaken on that?
Right. I think that if what you're describing is that in the real world, you don't see all the alternatives, right? So what if I've gone left instead of right this morning at the intersection? Mm-hmm. What would have happened, right? And that's one of the challenges, that if you basically collect historical data, then you're not going to see all the alternatives in that data. And that's one of the scientific challenges of in machine learning as well, is that how do you build simulations that can tell you what that alternative would have looked like, right? So in a way, the one of the big big advantages of simulations is that they offer a sort of what if analysis, right? But you have to understand when that what if analysis is going to be correct or close to being correct. And like if it's close to being correct, what is the error that you're making? That is something that is also related to causal analysis, for instance, where people do a lot of like what if analysis. I would say that is also still an area of research, but I think that is where hopefully in the future, if we understand this like better and better, that we can make these simulations better and better. And I think it gets to exactly the problem that you're getting at, is that these simulations can offer this view on alternatives, and then maybe they can offer it even before you take a new decision, right? And that could actually inform that decision that you then take even before you actually take it.
Yeah, exactly. So that was a little bit of a tangent, but let's get back to that other question that I had around, can you give me an idea of how you're training this? What data are you using to actually create these machine learning models?
Yeah, so for the current simulation, that we don't use any real data. It's purely a artificial construct. And for some listeners who haven't seen the simulation, it basically is this two-dimensional grid world. It's almost kind of like Pokemon, where these characters run left, right, up, down, and they can build houses. They collect some wood and stone, but all these things are programmed into the simulation without using any real-world data. Again, because we focus mostly on this two-level learning problem. And so, yeah, the only data, if you will, is just generated purely from these simulation rules, if you will. Yeah.
Later on, do you feel like you're going to start introducing data? And I just think about the complexity that you spoke about earlier and how difficult it will be to recognize what the real driving factors for each of these agents could be. Because right now it seems like the driving factor is, okay, I want to work to get money, right? And if I have too much taxation and I don't get a lot of money, then I'm going to not work. That's the simplified storyline, I guess. But in real life, it's much different. And maybe I work and I know I'm going to get taxed, but then I find a loophole or I send it offshore to my offshore shell account and I figure out, well, now I'm not going to get taxed as much, so I can not worry about that. Or like you said, there's so many other agents that are in play. There's the energy company, there's the different levels of government that are taxing. So it's so complex. How do you even begin to bring real world data into a problem like this?
Yeah, I think that you got to start small. That's what I would typically recommend. I think that there is this bootstrap process that most likely will be very helpful. I think that like the starting point would be to find some economic process or interaction where you can easily isolate it or isolate it in a reasonable way. And then the second thing is to I would say that a part of the story as well is that sort of collecting data in a responsible way about these kinds of processes is also something that requires some infrastructure maturity, right? Not every organization collects data like that. And so I think if you're a scientist, it's important, I think, to increase the complexity a little bit of the process, or look at maybe income taxation in a small place, for instance, or if you're interested in education, look at a single school where you can look at the student-teacher relationship. And and people have done studies about educational skill attainment, for instance. So people have done studies like that before, but they might not have really done so with this two-level learning as a context, right? So I think a part of it is, again, start small, isolate an interesting phenomenon. Think about like what the types of data are that you would need for an informed stimulation or an informed two-level learning setup, and then try to build up from there and demonstrate that it's useful. Before we start talking about the whole U.S. with all its complexity, or the whole world with all its complexity as a whole, that's probably too much too soon.
Yeah. Yeah, I like that. In Spanish, they say poco a poco. It's slowly, and you don't need to try and eat the whole cake in one bite. So, what are some next steps for this project? Are you going to continue with that? Are you going to start bringing in real data, or is there another challenge that you'd like to tackle before that?
Yeah, certainly we have a number of plans. I can't talk about all of them in public, but certainly we are thinking about how to demonstrate the usefulness of this framework. Certainly, we're very interested in sort of scaling it up. For instance, that's one sort of general trend, right? For things like this to be useful, scale very likely is something that would be important. And we also still do a lot of work on just the reinforcement learning algorithms that we use. So reinforcement learning is this process of training these AI agents, and part of we are primarily AI researchers, and then we are learning a little bit about economics, but we still have a very strong interest in sort of advancing these core algorithms that we're using to learn. And just as an example, one big question is like, how efficient are these algorithms? How much experience do they need, right? Like in a multiverse, how many simulations do you need to run in parallel? Do I need 1,000? Do I need 1,000,000? How long do these universes run for? And so, as you think about the real world, right? Like obviously, we hope that you can be as efficient as possible with the number of simulations and how long they run for. But that goes hand in hand with making the actual learning algorithms more efficient, and like how they, and sort of part of the question that we didn't really talk about, but like the learning algorithm tries to improve the policy, right? But can you sort of make sure that every time you improve by a big margin, right? And so those are the kinds of questions that we're also very interested in, sort of just developing these learning algorithms and making sure that that they can be run efficiently and that they learn efficiently.
It's fascinating stuff. I appreciate you coming on here and talking to me about it. I have one last question for you, then I'll let you go get back to this incredible AI economy problem, challenge, whatever you want to call it. So, Stephan, are you a robot?
Who knows? Maybe I am.
You've come to teach us a thing or two about it, huh? I appreciate you coming on here and explaining all of this. It's been super insightful, and I've learned a ton about how you are approaching these problems, why you're approaching them, and where you're going next. So I can't thank you enough. Have a great day, man.
Yeah, thank you so much for hosting this podcast and having me. It was a great pleasure to talk to you about this. Yeah, thank you so much.